This is my workbench, and I'm going to be showing the SSG Bedini motor as the piece that I constructed and all the parts involved in doing the load testing. So first over here is the actual Bedini motor, power supply, circuit, coils, volt, amp meters, batteries all marked. I use a battery load tester instead of like an inverter, and it's all computer controlled, and so that helps a lot with accuracy. First steps here was building the Bedini schoolgirl motor. The motor is comprised of a 24-inch bicycle rim that is aluminum framed, stainless steel spokes, and the first thing I did was take the bearings out, grease them up really well, and put it back together, and I left them quite loose so that it spins a lot easier. I used water pipes for the supporting frames, which are steel, which aren't the best for this application. So I actually used 16 ceramic magnets instead of 8 to kind of compensate for the magnetic drag of passing by the steel. And it seems to work very well. I tried plastic, which made it wobble, but I got the same bolts out when I switched to steel, which supported it better. So here's a little tour of the build. There is the coil, which is about, I believe, about 800 or so turns of bifilar wire. It's magnetic wire, and there is, I think, 23 and 26 gauge wire wrapped concurrently, simultaneously, up and down the coil. In the center of the coil is R60 steel welding rods, and it's just secured to a block. Because it's a bifilar coil, there's 4 wires that come out of the coil. You can see there's one of them there. There's another one back there, and let me switch sides, and you'll see the other 2 right there. So 2 come out of the top, 2 come out of the bottom. One runs down into the power supply, which could be just a 12-volt battery, but I'm using a power supply because I just didn't want to keep that 12-volt battery charged if need be over a month or so while doing the load testing. So this allows me to precisely see and regulate the current going in and the voltage going in, and it's got a nice setting to mimic a battery, 13.8 volts right there. It works kind of well, but the odd thing is that the needle seems to be off, registers high from what my meters tell me. So if I dial it up to about 15 volts, it shows about 13.8 actually, which is a little pain in the ass. So the next thing in the construction is the circuit. The circuit is very simple. It's very straightforward. It's made up of a couple components, a couple diodes, a neon bulb, a couple resistors, a 12-volt bulb, 2 close, sorry, and a variable resistor, 1K ohm. And I use this little connector board to connect the kind of heart of the system, the transistor, which worked well. Just got to be careful you don't snap the pins, but they do bend fairly easily with a pair of wire benders, kind of. And there's the wires coming from the coil and viola. So there it is. First thing I do is I just take any schematic and I'll draw it in a very simplified form, so I can just make sure that as I'm assembling it, that it goes together exactly the way it's supposed to. There's the 1K, the 100, the light bulbs, the 2 diodes, the neon bulb, and then out to the screw board, the transistors, the wiring pattern, 2, 3, 4 EBC for the transistors, the power supply, and the 2 batteries. So nothing fancy here. And I did my best not to deviate from any of the specs on the Monopole 3 user group, since that's what this is all about. Lastly, I've got a little piece of reflective tape right there that is used with a digital tachometer to measure the wheel RPMs to kind of tune the circuit, or tune the SSG rather, to spin as fast as possible while drawing as the least amount of current from this guy over here. And the next thing I did is I went out and got myself 3 identical batteries. Found them, actually went to 2 Radio Shacks, found one that had a bunch, but the date stamps were completely different. Some of them were even 2004 date stamped on the shelf. So I've learned a lot about batteries. They're 12 volt, 5 amp hour batteries, and I've labeled them normal charger only. And I've got a conventional wall charger, a wall wart, that's like a 12 volt, 500 milliamp charger, and then 2 batteries that I'm testing radiantly. If you notice, they're labeled bad and good, and this was something that I wanted to experiment with on my own, and I deviated a little bit from the instructions of the group. I was interested in seeing what effects the SSG would have on a bad battery, and by that I mean one that was severely drained. So this bad battery, the first thing I did is, when I got home with both of these, is I loaded them up to kind of drain them to prepare them for their first charge on the SSG. And the bad battery, I took it down until it literally turned off this bank here of light bulbs. And so what I do to load it up is I just, power up in series some light bulbs, and I let it run. I drained this battery down to, I think, about 6 volts on the meter, which is literally killing it. Expecting it, not to perform ever again as well as this one or even this one. Well, that is not the case at all. This particular battery, I'll just give you a little glimpse here of the future, is showing numbers like that in the COP. Twice, there and there, and that was absolutely a shock to me. COP8, COP1, COP1. I haven't finished the last test yet. I'm going to do that tonight. This battery, number 2, did very well, but I don't think I ever saw a 1.0 with this sucker. In fact, it didn't do as well. I mean, that was the best I got out of it, a 0.9 on one of the trials. But this battery didn't do as well as the one that I literally destroyed. So what this kind of tells me is that the SSG does something to the batteries, and it likes batteries that are starting from a state of almost 0 before building them back up. I'm not saying draining it completely to dead, because from what I know conventionally, that's not a good thing, but I just wanted to experiment and see what that did, and I am finding that draining the sucker almost down to the point of just killing it. Yeah, well, there it is, you heard it. So now what I'm going to do real quick is show the procedure that I use for load testing. The first thing to do with the load test was to measure current out, and so I'm using a standard Radio Shack analog amp meter here, and I would just put it in series here between here and here and measure the milliamps out, and let me see, I have my specs here. 75 milliamps of output, 5.5 volts measured on the input batteries, which constitutes 0.4125 watts multiplied by an hour, and I get 1,485 joules per hour that the machine runs. The next thing I would do is, and this is a little deviation, I noticed that my batteries were charging up fairly quickly compared to some of the others that I'd heard on the group that were talking 20-hour charge times. Obviously, the next thing I would do here is I hook up my battery You know what, I have to make sure that I'm not about to charge up a battery that needs to be load tested. Just one second. Okay, this battery is just about to go through load testing. This one is just ready to go back on the charger. So the first thing that I was doing was I was hooking up my batteries in series. So I was hooking them up this way, like this, to the SSG. I did a couple different load tests, both directions, single batteries by themselves. Actually, I'd let this one charge by itself, and then I'd load test it, and I'd let this one charge by itself, and then I'd load test it. And then I started doing tests of these guys hooked in series, actually in parallel at first, and parallel was awful. They just balanced each other out, and regardless of one's volt, the other was always at the same voltage. Once I started charging in series, I saw that they were acting independently. One of them could go up as high as, you know, 13.8, 13.9, or even 14 volts, while the other one was still 12.9, just beginning its charging. And I did a few tests, and I noticed that they were acting almost identical to being charged independently as they were being in series. It saved me quite a bit of time to charge two of them together, and in the end what it allowed me to do was to do two battery tests at the same time. So I have a sheet here for all the specs on battery 1, and a sheet here for all the specs on battery 2, and you know, just wanted to see. So with the battery connected, we'll kick on the power supply, give the wheel a little spin here. It's a monopole. I don't have to tell the group, but it's a monopole motor, so it's not a self-starting motor. Take a minute or so for it to get up to speed, and we'll see here. You can actually hear it getting a little faster and faster. I'll put the mic near it. Just to illustrate here, is I would use a digital tachometer or laser tachometer and just hit the reflective tape. It's going to give a low reading, but you can see that, no, you can't see. Yeah, it says about 118. And it's not yet up to speed. Normal speed for this is about 138. But it usually takes about 5 minutes. You can see here, I'm actually pushing the 12-volt bulb a little bit. It's glowing just a tiny bit there. Not much. And the neon protection bulb has no problems. If I disconnect the lead here, kind of protecting the transistor. Hey, it's aliasing too. It's not really flashing like that. It's kind of strange, actually. Okay, so once I charged them up for about 12 hours as best as possible. Take them off the power supply. Obviously, I'm not going to use this one. I've already charged, and that one's already gone through its test. The next thing I do is I hook them up to the CBA, Computerized Battery Analyzer. And once this is hooked up, then the work is primarily done by the computer. I'm going to let this thing run for a second. Once that battery is hooked up, which it is now, the next thing is to enable it to start load testing. I use the CBA software that came with it, or the battery tester software that came with it. Each test is given a name. This is my Radiant Battery 2. And this is actually about my, I don't know, my 40th pass at this. As you can see over here, I've got just piles of tests. Round 1 for the conventional battery and the two Radiants compared. Round 2 was the Radiants separated out to see how they did on the SSGs independently. And final round is the actual final load test that I was going to turn in. So then I name the battery test. I choose that it's chemistry. These are lead acids. It's amp hours, its voltage. Oh yeah, I gotta plug in the meter here. It's a USB device, okay? And then it starts to make guesstimates. Hey, look, there's the voltage of the battery. It starts to fill in some of the data with what it thinks you want. So I'm going to throw this on 12 volts. It's got 6 cells. I'm doing it a little bit above the C20 rating, just because I want my tests to be done a little bit differently. And my cutoff point is 12.5 volts. So hit start. The CBA spools up. It's got a cooling fan in it, which you can hear. And then the tests start going. You know, it's starting off high and it's coming down. It'll probably level itself off. I don't know, but you can see the line here too. That's its cutoff line where hopefully it doesn't hit right away. And at the bottom it's over amp hours. And when the test, it's going straight for the line. It looks like it's not going to last too long. And when the test is running, the CBA kind of has some nifty lights. I don't have it, but it's got a temperature probe that you can attach to the batteries. And so there, it's starting to level off. It's going to, if it hits 12.5, the test is going to end. It's 12.56 right now. There's the current draw, the amp hours. It's 9 watts is a little high, I know, but I'm willing to push my batteries to the extreme. So this test is going to end in a minute. 12.52, 12.51. I think if it hits 12.49, it shuts off. And yeah, this isn't very exciting. Jump ahead a couple minutes here, and this thing is still going. This is why I picked 12.5 as its kind of sweet spot. Notice it's recovered. It's springing up to 12.53. I noticed that if I took it down lower, it didn't seem to make that much of a difference, and if it was too high, it would just shut off too early. So 12.5 is, see, check that out, it's going back up. 12.54, I just saw it 12.56, there's 12.55. So this is kind of the spot where the battery seems to last the longest. I'm sure the test would last longer if I took it down to 11.5. But I can see this kind of granular turbulence right around 12.5, and I wanted to kind of explore that a little bit. It actually is like 64 in my garage. I'm freezing right now. So while we wait, there's not much else I can show you, so I'm just going to kind of cut this off, and I will come back in a minute and show you the next procedure after this. Is another 5 minutes has gone by, and this thing is still jamming along. It's climbed back up to 12.56. Essentially, I don't know, it's recovering some of its power as it's draining at the same time. It's just kind of phenomenal to watch it. I've seen other batteries do this. These cordless phones, they have, I think, oh God, I can't remember the type of batteries that are in here. They do the same thing. When I put them on the load testers, they will drain and drain and drain and spring back up, down, up and down. And while we wait for this test, I thought I would show this little sucker. People just love this little sucker. It's just a AA battery, but you pop the top off and you charge it on any USB device. Yeah, it's pretty snazzy. I found this in the UK. I can't remember where. It lights up. It's got a nice little light up ring. Anyway, back to the test. Test complete. You know, you never have any idea how long this stuff's going to take, but that thing sat on there for at least 5-10 minutes. So what I do next is I take the data here, save it as a CBA native file, and then I export it out as a CSV into Excel. And once I close the load tester, it shuts the battery, or shuts the fan off, and I can unhook the battery. The next step, going really quick here, is that I will open up the data, the CSV file that I just put out, and I will open up the previous file. You will see why in a second. I will take the CSV file that comes out of the load tester tells me amp hours, or tested, was rated at 0.8 amps. Tells me a little bit about the battery, and it takes readings per second, so I can see the voltage per second here, and you can see how far down it goes, essentially by multiplying up the number of cells in the spreadsheet. You can tell how many seconds it went, 701. So what I did is I expanded their little output a little bit by adding the amps, by taking the volts times the amps, and I made this into a very simple calculation that I move into this field. Or into this document, and this is just a calculation per frame of what the amps were. And now I've got to remember the bottom number, 701, and plug that into my formulas. 701. You can see the last time it went only to 437, so 701. Then I've got my amps. Got to make sure that I go 701, 701. My time, I just count up the cells, more or less. 701. And the joules is, the amps over time. I take this data, 692 seconds is how long battery 2 lasted. And I plug it into my sheet here. Battery 2 lasted 692 seconds, 10.03. And this test time around for battery 2, I got a COP of 0.331, which is, I don't know if it's fairly good or bad. I've seen some bad ones, 0.04, and I've seen a phenomenal one, which is a 0.9. And so this is the procedure for load testing that I've been doing for both batteries. This is the data that I submitted to the group, and this kind of concludes the process. Thanks very much.